Hey everyone, it's Mr. B back with another video notes for you as you finish up your lab. You should be able to watch the notes here and understand the first part of the section, which is dealing with analyzing water on Earth. So far in our chapter, we've been talking about how air kind of circulates. We've talked about how ocean water is going to circulate, and now we're going to talk about how the water cycle works. So let's get into it. So we need to give definitions of the different states of water, also known as states of matter. And our three different types are going to be solids, liquids, and gases. There is another form called plasma. We don't touch on it this year, but you'll learn about that as you go through your schooling. A solid, by definition, is going to be any object that has a definite shape and a definite volume. Okay, so it's going to be those molecules. If you look down in the solid part here, you're going to see that they have a definite shape and a definite volume. They're going to be in a fixed position. Um, and a liquid, and by the way, for a solid, if it has a definite shape and a definite volume, it's going to be in the form of things like ice crystals or snowflakes or hail. Okay, so water in a solid form is going to be ice crystals, snowflakes, or hail. The liquid, which is the one that's right above it, is going to have a definite volume, which means that whether you pour it into any type of container, it's still going to be the same amount of water or liquid, but it's not going to have a definite shape. Right? If you try to put a solid um, into a different container, it may not fit because that shape of the solid isn't going to change. But a liquid, on the other hand, is going to take the shape of whatever container it's going in. So if we put it into a beaker and then we pour it onto the floor, obviously it's going to spread further apart. And so it doesn't have a definite shape, but it does have a definite volume. That amount of water that's on the floor is going to be equal to the amount that was in the beaker at one point in time. Um, Water in liquid form can be rain. And it's also what's going to help us to create rivers, lakes, and oceans. Gas is not going to have a definite shape and not going to have a definite volume. Okay, so that is the example that is up a little bit higher. And because of the fact that it doesn't have a definite shape and a definite volume, the molecules are going to continue to spread further apart. And remember, we're talking about molecules of oxygen, hydrogen, if we're talking about water, and so H2O, those molecules are what we're referencing. In gas, again, no definite shape, no definite volume, so it will take the shape of whatever container that it's in, or no volume, so it'll continue to expand. And an example of this in liquid form would be water vapor, which is the water that is in the air. So we can actually change from state to state. All right, so evaporation, which is the process by which molecules at the surface of a liquid absorb enough energy to change to a gas. Okay, so at the surface of the water, that's where evaporation will begin to occur, and it has to gain enough energy to be able to go from that liquid to gas state. Okay, so it takes a certain amount of energy to be able to generate the liquid to a gas state. And we know this happens if you've ever spilled something or left a glass of water out for a period of time and you come back, you'll notice that some of that water is gone, or if not all of it is gone. And where did it go? Well, it gained enough energy to be able to convert from a liquid to a gas. Boiling, very similar to evaporation, but boiling occurs at both the surface and the bottom of the liquid. Okay, so if you've ever had to boil some water on the pan, you'll notice that it will start to bubble at both the surface and from the bottom. And again, this is a conversion from a liquid to a gas. Boiling water occurs at 100 degrees Celsius, or in Fahrenheit, 212 degrees. Make sure you write down those numbers because those numbers you're going to need to know. Another form is condensation. This is the process of changing from a gas back to a liquid. Um, if you've ever taken a really hot shower and you've noticed that there's a bunch of looks like moisture or water that's collected on the mirror after that hot shower, that's condensation. It's where the gas, remember that's a water vapor, so the water that's in the air cools or loses enough energy and becomes a liquid, and it begins to collect on the mirror. You can also do this if you were to get real close to a mirror and breathe out, because of the fact that we breathe out water vapor. And the mirror has a cooler surface, so some of the water will collect on there. That's a form of condensation. Another change of state is called freezing. This is where the molecules in a liquid lose energy and they start, sorry, that's a stat, but it should say start to move slowly. Um, so it's a conversion from a liquid to a solid. Again, a loss of energy. This occurs at 0 degrees Celsius or 32 degrees Fahrenheit. Again, I'd write down those numbers because you're going to want to make sure that you have those. Okay, so freezing is the conversion from a liquid into a solid form, and melting is the molecules in a solid begin to move faster and faster, so they're generating enough energy or gaining enough energy. And this happens also at 0 degrees Celsius or 32 degrees Fahrenheit. Again, write down those numbers. You may be thinking to yourself, Mr. B, freezing occurs at 0 degrees Celsius and 32 degrees Fahrenheit, and so does melting. How does that work? Well, if it's already in a solid form and the temperature goes and is increasing, up and it hits at 32, it's going to begin to melt. However, if it's in liquid form and the temperature is dropping and it goes below 32 degrees, it's going to convert into a solid. So it's going to be freezing. So it depends on the movement of the temperature, whether it's going from a solid to a liquid or a liquid to a solid. Okay. And this is our last note. This is kind of just showing you the changes of state. You can ignore the solid to gas on the right side over here from solid to gas. We may touch on that one a little bit, but for the most part, you just need to make sure that you understand when it goes from a liquid to a gas, it is considered to be boiling. From gas to a liquid, it's called condensation. From a liquid to a solid, it is called freezing, and from a solid to a liquid, it is melting. Okay, I might copy down from solid to liquid and liquid to gas these boiling, condensation, freezing, and melting. That might be useful for you. Okay, that is it for notes. We will talk about some of this stuff a little bit more in class. All right, take care.